Now this illustration illustrates applying the 50% load diversity factor where you're loading more than half of the conductors in accordance with Table B.310.14b.2, Item 11, and Section .B.7a. Now with that, those sections listed, the section with the table, let's look at the quick calc above. Applying your B table 310.14b211 and section B.7a, notice that we have A2 listed as a formula, and in the square root we have 0.5, 50%, times the new number divided by E times A1. Now let's look at exactly what that means. In the second bullet, A2 is equal to 0.5 or 0.50 times 16, that is 16 conductors, divided by 16. Then we would come up, A2 then would be the 707 times 30 amps, we come up with 21.2. That's loading half of the conductors. But now the quick count 2, we are dividing 12 wires of the 16. So now a new formula is presented, but you got the table and the section that lists this. A2 is equal in the square root 0.5 times the number divided by E times A1. Now let's look at exactly what that is asking or saying. In the square root we have 0.5 or 0.50 times 16, the number of conductors, divided by 12, what we're loading, times A1. So A2 is equal now to 81% times 30 amps times 70%, and the new ampacity is 17. What's the next size overcurrent device above 17? 20. But you can only load the ampacity to 17 amps. And you'd say, well, I don't trust that. Then you'd have to use the next size conductor, which is number 10, where you could get a full 20 amp conductor. But notice, this is a permissible way to do it, but always talk with authority having jurisdiction, because the method in the Annex B, with my experience, has always had to be approved by the authority having jurisdiction. And notice that your 81%, when you do your math in the formula and you take the square root of it all, this is where these figures would come from. The 70%, you're loading half. The 81%, you're loading 12. And when you do the math times the 30 amps of the number 12 from the 90-degree column in your table 310.16, that's where the 30 amps comes from. And when you apply this diversity factor method, figure 8-16 is illustrating how this should be performed.